Hello and welcome to another Commander X16 update video. So we have 1,000 more of these in production as we speak, and I'll get into that more in just a minute. But for the moment, I just want to let everybody know, in case you don't make it to the end of the video, that we're actually taking pre-orders for those right now, and I'll put a link down in the description. I think there's about 250 of them already spoken for, but if you want to get your name in, now's the time to do that. I have a ton of other updates to tell you about, so let's dig into it. Kevin and I recently took a trip to Mouser Electronics. Since we live nearby, it made sense just to go pick it all up. We filled Kevin's car up pretty full, even had to use the frunk. Believe it or not, there are 321 individual parts needed to build an X16 motherboard by itself. If you multiply that by 1,000 boards, that's 321,000 parts we needed to buy. Mouser is usually our default choice, but we did source parts from all over the place. This pie chart represents a breakdown of dollar amounts spent at each vendor. Interestingly enough, we did buy the 6502 processor and support chips directly from Western Design Center, and of course we got the PCBs from PCBWay. Now I should mention that PCBWay is actually not sponsoring this video, at least not directly. They are, however, sponsoring the Commander X16 project by giving us a very generous discount, and I'll do whatever it takes to get the cost lowered on this project so that more people will be able to afford it. So a big thanks goes out to PCBWay. Okay, so a few quick things to get out of the way. I've shown the X16 working with Commodore disk drives in the past, but many people asked if you could use a printer, and well, nobody had tried it until recently, so here's the X16 printing to a Commodore IEC style printer. And as you can see, it works fine. Kevin also recently connected a parallel printer up to the user port, and while the kernel doesn't support this directly, he wrote a little program to print something to the printer, and that works too. Okay, now I want to show you the latest case from Laser 3D, which is a third-party product. This is the original prototype case that I've been using for a while, but I've gotten in a newer model, and even this one isn't exactly finished, but it's closer to being finished. I will reiterate that the computer does not come with a case, and we do not currently have a case of our own. It's a standard micro ATX form factor, so you can put it in whatever case you want. The Laser 3D case is available in different colors. This one is black, for example. Anyway, so what I'm going to do is move the board over to the latest case. As you can see, this lines up much better with the ports. Now, one of the new features is this reinforcement bracket, which should help if you're sitting a monitor on top of the case. I also want to show you the buttons, which actually light up. So here's the power. The button on the right is the reset button, but also doubles as a drive status light. So much like the old Commodore drives of the past, when you have a drive error such as a file not found, the light would blink. And we have that same behavior here, only it's a blue light. Hopefully someday we can make that a red or orange light, but anyway, it works. Notice that the new board has a right angle connector. This is for cartridges or any sort of external bus device that you might want to connect. Unfortunately, this case doesn't have a slot for it yet, but here's a photo of a prototype at Laser 3D, and you can get the idea of how it's supposed to look eventually. And now I want to show you a new add-on card. This one is an extra video card. Basically, it's just a duplicate of what's on the board already, but will be controlled from different memory addresses. It only has VGA and S-Video as there's not room for the composite port, but if you need composite, it will also come with this little pigtail which creates composite from the S-Video jack. Now, a lot of people have asked, how would you install a card in this tiny case? And I've been promising a riser card, and now here it is. So you just stick the card in here like so, and then you can fit it down inside. Now, unfortunately, there's no sideways slot in the back of this case yet, so I had to cut my own, and it looks kind of ghetto. But don't worry, we plan to have that corrected in the future. We don't have much of any software developed for two monitors yet, but here's a little program I wrote in BASIC. Basically, it just activates the card, copies over the font data from the other card, and then copies all the text on the screen, giving us a duplicate of the first. Although clearly, as you can see, these monitors operate independently. Oh, and check this out. The card has an I/O selection on it. Technically, you could add more than one of these to the system. And so here's how that would work. This would be your main monitor connected to the built-in video card. And then you could add either 1 or 2 additional monitors. And believe it or not, you could have as many as 5 independently controlled monitors. The catch here is that the first 3 would be running at a full 8 megahertz. But because the way the bus is designed in the X16, the other 2 would be running at 2 megahertz. Which is not really that big of a deal in most cases. But as far as what kind of software will eventually make use of this, the possibilities here are endless. Kevin has also been working on a network and serial combo card. He does at least have the serial portion working already, as you can see here, dialing out on an old school modem. Okay, so now that I've talked about all the new hardware, let's talk about software updates. So just one quick thing, we have added all of the usual Commodore disk wedge commands. So if you're accustomed to using things like the @ in order to get the disk status, or do disk commands, or using like the / in order to load a file, that all works now. So all those who are, been using those commands for decades on your Commodore, well, they work now on the Commander too. But one thing that has been really the focus lately is I wanted to have a computer that people could sit down at the computer and actually write code. I mean, up to this point, most of the programming has been done on, like modern PCs or, Linux or Mac or whatever, and then cross-compiled over. But that's not the end goal. And that's because while right now the primary market is the retro computer hobbyist, I really feel like the larger market down the road will be the educational market for kids. Now, over the years, there have been a bunch of different educational computers marketed for kids. The coolest one, of course, was the Tiger Learning Computer, which was basically an Apple II. Unfortunately, it was pulled from the market when Steve Jobs took back over Apple and canceled all of the licenses for third-party companies. All of the rest of the educational computers have basically been crap, in my opinion, and that's because they include a few boring programs for kids to play with, and then usually don't offer any way for them to be creative or to write their own programs. And a few of them over the years have actually included BASIC, but it offered no ability to do graphics or sound, or even to save your programs when you were done, so it was fairly pointless. I'm envisioning a computer that parents could get for their kids that is literally incapable of doing all of the things that people worry about with kids getting online. Everything from ultra-violent video games and pornography and scammers and viruses and all the pressures and stuff that come with social media and all that kind of stuff. The Commander X16 literally can't do those things, so you don't have to worry about that. But at the same time, I'm looking at a computer that doesn't hold kids back. I've looked at some of these educational computers out there on the market, and I feel like they really underestimate kids' intelligence and ability to understand things. I mean, when I was 6 years old, me and my brother learned how to program our VIC-20 simply from reading the user's manual. And within just a few minutes, we were writing our own programs. And within a few days, we'd actually become pretty good despite not having anyone to actually teach us, how some of these things worked. I think one of the reasons that we were so mesmerized with the VIC-20 is that it wasn't technically a kid's toy, right? I mean, I think if we'd been given one of those educational computers, even one of the ones that came out in the 90s or early 2000s, I mean, we would have probably played with it for 10 minutes and then we would have been bored with it and, put it on the shelf and it would have gone out in the next garage sale. And so I wanted to create a computer that would bring back that magic to modern kids. And so I made a list of programs about a year ago that I felt we needed to create and put into ROM, since we have a lot of ROM space. Not everything on this list is done yet, but let me show you some of the things that are done. Eventually, I want to support multiple languages, but for the moment, we've been focusing on BASIC. Now, BASIC is a very powerful language, and it's easy to learn. I learned how to start writing my own programs on the VIC-20 at the age of 6 in a matter of minutes just by reading the manual. Unfortunately, BASIC has an Achilles heel, so to speak. Actually, it has two Achilles heels. One is the editor, and the other is speed. Using line numbers is okay for short programs, but once you start getting into source code that's multiple pages long, it becomes completely unmanageable for a number of reasons. One problem is all of the goto and go-sub statements use line numbers, which isn't really human readable. Another problem is lack of formatting, like tabs or spaces between the lines and proper comments. It's also a real pain to move code around in the program. So let me show you what we've come up with here. At the basic prompt, you can type menu to get a list of built-in programs. Now there'll actually be more later on, which I'll talk about shortly, but for the moment we have these. Now let's start with a text editor. This has been written by Stefan Jacobson, and the interface and operation is based on GNU Nano. You can open any sort of text document, but you can also use this to write and edit source code. Now, let me show you an even easier way to do this. If you know the code you want to edit, such as this demo.base file here, you can just type edit demo.base, and there you go. It opens right up. Now, I know this code doesn't look like traditional BASIC, but it is. We've just eliminated the line numbers and substituted them with labels. Now, if I press a hotkey, I can tell the editor that I want to compile source code. Now, the only compiler we have in ROM right now is baseload, which translates this over to tokenized BASIC, but we eventually hope to add a C compiler and a 6502 assembler here too. Anyway, if I use baseload, then I can immediately exit to BASIC, type list, and now you can see the BASIC program there ready to run. And there we go. This is a little kaleidoscope program that I wrote. So I think we've solved the editor problem. So let's take a look at the speed issue. Our approach to speed rests on 3 strategies. The first is obvious. We have 8 megahertz. I mean, that inherently gives us an 8x performance boost over the Commodore 64 or similar machines of the era. So let's talk about the second strategy, better commands. Well, in the olden days of the VIC-20 and the C64, you had to poke and peek everything in order to create sound or graphics or even manipulate screen RAM in text mode. Now, this was inherently slow. The C128 came along and added commands for a lot of things like sprites, graphics, and sound, and that made BASIC somewhat more usable beyond text applications. Well, we've also added commands to BASIC for things like graphics, sprites, sound, music, file system access, and tiles. Now, let me give you an example of how this can speed things up. In the past, if you wanted to put a character or a tile on the screen from BASIC, you'd need a command something like this, which has some math in it to calculate where your character will go. So if you wanted to fill the screen using a loop, you can see how long that would take. But if you substitute the tile command, not only is it a lot cleaner, but it's actually about 2.5 times faster to execute. In fact, let's compare this to the same idea on the Commodore 64 and see what kind of speed difference there is. And so we've added a bunch of stuff like that. Now, let me give you another interesting example. I wrote that same kaleidoscope program on the Commodore 128 using its built-in graphics commands. The code is almost identical here. And for giggles, I also wrote it on the Apple II. Now, I'm not sure why, but the Apple II runs this about 1.8 times as fast. Now, let's look at the Commander X16 version. It's running 11.7 times as fast. Most of this speed difference boils down to the faster CPU and more efficient line drawing routines. But what if we could make this run even faster? So, our third strategy is Blitz. Paul Robson coded this from scratch for the X16, and it works just like Blitz from the olden days. So I'm going to save my little demo program here as a source.prg, and then I'm going to load Blitz and run it. Now, for those that don't know, this basically compiles your BASIC program into a more efficient type of code known as P code. So let's run the blitzed version and look at it go. This is now running 30 times faster. Eventually, Blitz will be in ROM, so you can just blitz your programs just by typing blitz at the command line. So one way of looking at this is that if you go back to the C64, and if BASIC is considered the standard, I've always heard assembly programs run about 100 times faster. So BASIC on the X16 would kind of slot in right about here. So while it's not powerful enough to do really fancy games like this, I absolutely believe you could do games like this written entirely in BASIC. In fact, I bet you could do a game like this, and probably even this. Basically anything that doesn't have a ton of screen scrolling could probably be done. So let me show you a few basic programs that we have now. These aren't even blitzed. These are just running at regular basic speed. This one constructs a picture. This one is a ray tracing program, which is very slow because it's doing some very complex math. This one is one of the more impressive programs. It's a labyrinth maze program that works in 3D. It's very impressive for BASIC. It even runs faster when blitzed, as you can see here. Unfortunately, there's a small bug in the blitzed version, so certain things aren't drawn correctly, but we'll get that fixed soon. So let's talk about some other things on this list. Matt Heffernan is working on a sprite editor, and as you can see here, it's not in ROM yet, but you can load it as a standalone program. It's mouse operated and it's quite powerful. The program edits what is in video RAM directly, and then you can load or save your work. The idea is you can use these directly in your own software, either from BASIC or assembly language. Now, what we're looking at here is the tile set for Planet X16. So the last program to show here is the hex editor that is already in ROM. I wrote this one myself. It's fairly powerful, allowing you to directly look at and edit system RAM, video RAM, or even a file mode if you just want to edit a file and not RAM. It has most of the features you might expect, including the ability to select areas for cut, paste, or saving to disk. Okay, so I have a few more new programs to show you, like this firmware update program that Sven has created, which will update the ROM, the keyboard microcontroller, and the Vera FPGA right from the computer. That way, as new firmware becomes available, everyone will be able to upgrade easily. I also want to show you this little demo. It's not a full game, it's just a proof of concept to show that we could actually run something similar to Mario Kart on this computer if somebody wanted to take the time to code it. This is Scumbotron. And this is a proof of concept for Mega Man, and it actually runs in high-res tile mode, which looks spectacular. And here's Munchmania. And here's Quack. I've shown this before, but it's improved a lot since last time. This is Potions. And here's Vault of the Vindicator. It's kind of a 3D dungeon crawler. And this is a recent game from a YouTuber called Inkbox who created a Minecraft-like game on the X16. And I've been trying to reach out to people to port their games to the X16. For example, Jim Orlando recently converted one of his pet games over to the X16. This one's sort of like Super Mario Brothers. And while at the moment it's a direct port of the pet version, I'm hoping he'll at least add some color eventually. I've also been in discussion with Knights of Bytes about possibly bringing Sam's Journey over to the X16, but it's really hard to find contact info for some of these people. So I'd appreciate it if you guys could reach out to your favorite retro publisher and ask them for X16 versions of their games. I'm also looking for somebody who could do any sort of 3D game, whether it's a filled polygon type game like some of these from the past, or a textured game like Doom. We may even be able to offer financial compensation for such work, so if you know somebody that can code that type of thing, then send them my way. And there we have it. So there's 120 of them-ish out there in the wild right now. We're producing another 1,000 as we speak, and we plan to continue to produce them in batches of 1,000 after each batch sells. Now, I know a lot of people have said that they're going to hold out for the cheaper second generation unit, and that's fine, but I did want to point out it's probably going to be like 2 years before that unit is available, and we're depending on the sales of the first generation unit in order to fund the development of the second generation unit. So I hope not too many people are holding out for the second gen. I've also had a lot of people ask about having distributors in like Europe and Australia, New Zealand, and places like that. And I just gotta say that, we're basically a two-man operation at this point, right? I mean, yeah, we've got a lot of people working on software. I mean, dozens of people working on software. But when it comes to the actual hardware side of things, there's really only 2 people. Actually, more like 1.5, because Kevin Williams is really doing the bulk of the hardware on that. So, I mean, it's a little bit of a stretch at this point to ask us to have like distributors all over the world. Now, hopefully someday, maybe that'll be a possibility, but it's just not yet at this point. But anyway, that's it for this episode. I'm sure I'll be back in early 2024 with another Commander X16 update. Hopefully we'll have a lot of more cool things to show you then. That's it for now. So as always, thanks for watching.